Alrighty. So welcome back if you took a quick break. Next up, we have Melissa Santos, Senior Data Analyst at Pingboard, presenting time to event analysis for non-medical applications. Melissa, just a reminder to start your timer and enjoy, everyone.
Hello, I'm Melissa. I work at a little company called Pingboard, and we're a software as a service company that gives organizational chart and directory software so coworkers can get to know each other better. So that's the frame in which I'm talking about time to event analysis. So usually time to event analysis is called survival analysis, and you think about it in terms of things like how long someone lives after a cancer diagnosis. But I want to show you a couple of examples from what I use at work and how you can use it for other things. So we'll talk a little bit about right-censored data, and then we'll talk about estimating the survival function. I have a couple of real-world examples, and then if you'll forgive me, I'm going to go into the sequel for estimating these Kaplan-Meier curves, because I think it's both interesting and it gives you a little bit of how my work goes. So right-censored data is on a left to right timeline. So as time goes by, at some point, maybe today, you don't have any information about what happens to the data after that point. And so the future is unknown, and you can't tell information about the whole population of the data anymore. If I wanted to know the average length of these lines, it's not obvious how I would get that from the data that's visible. I could take the average of the visible lines, but we're pretty sure that some of the lines continue to go on past that. So we know that number would be a little too low. Not all right-censored data is so nicely lined up. Especially data in the real world, like what I've got in my examples. Somebody could become a customer 4 years ago or last week, but I still have data about the first week of their existence as a customer. And that doesn't have anything to do with when they're censored. The censored data is just about whether we stop observing them before the event happens. So how would you find a midpoint when so many points are unknown? Maybe that's not even the right question. A lot of the time I get questions phrased like this, where somebody asks me something like, what's the average time until someone sends an invite? What's the average time until someone stops being a customer? And those are kind of interesting, but they don't take into account that there's a lot of people who may not do those things or may take a long time to do them. So often the correct answer to a question like this is not to do some time to event analysis, but the correct answer is to say something like, let's look at how many people do this for the first time in the first 7 days, or something like that. But we still can do survival analysis and get some more data. So Kaplan-Meier curves are the empirical estimation of the survival function. And the survival function just tries to show you what proportion have not yet reached the event for a certain time. So in this example, the percent that have not yet, 97% have not yet reached the event at the 2-month period. Kaplan-Meier curves are really cool. They're non-parametric. They approach the true survival function. And even though the data can be lined up like that, they use the data from when you start observing it. So it uses all the data available for every given time period. And the way that we estimate it is this product function, where we look at 1 minus the number of people who have hit the event at time I over the number of people we know about at time I, whether they're censored or not. And one thing that isn't obvious from this particular screen is that it's not often that you actually get this empirical estimate to go all the way down to 0. To get that to go to 0, then the DI over NI would have to go to 1 So everyone that you know about would have to have hit the event. But we know that we have right-censored data, so we know that not everyone is going to hit the event. So a lot of these survival curves are going to actually taper off and plateau out at some point. But if they don't, you can actually answer your midpoint question. You can look at the 50% survival point and find out where that is in time. And now you have your answer for what's the, how long on average do the subjects survive? How long on average does it take to send an invite? Whatever it is you're interested in. And that's kind of cool, but you also have this whole survival function curve, and that's even cooler. This tells you a whole lot more information about what's going on. And so here's one of my actual examples. We are a software as a service company, so we really care about people continuing to pay us for software. And so we want to know how long people are going to be customers, and so how long they stay paying customers. And so having this probability laid out over time is really helpful. But that's not all. What if we looked at different groups of data? I like this example because it's so very clear. When we bill monthly versus when we bill annually, the probability that they're going to stay a customer for those first 30 days is lower for annual customers. They're a little more likely to rethink such a big decision. But after they stick around for the first 30 days, then you have this probability that there'll still be a customer after 1 year is about the same as the probability that a monthly customer will be a customer after only 2 months. So this informs a lot of our decision about how we want to price our annual subscription, how much we want to push that on customers and make that an option for them. And this is just something you can do for any kind of group. We've done it for people who use certain features, and we've done it for different plans of customers. And I know that doing this in SQL is maybe not the most obvious thing to do. Probably if you're going to use survival analysis, you're going to do something in R or Python, and that's great. But I live in dashboard land. I live in Chardio. And so I want my numbers to change over time and to continue to be updated. So being able to do it directly in the SQL really helps make things available to the data available over time. If I did this in Python, I would have to manually update those dashboards whenever I wanted new updated data. Whereas if I can do it in SQL, then it just automatically pulls in more data every day and they stay updated. So there's a couple of SQL tricks we use. We will generate a list of numbers. We'll sum results of a case statement because we need to know which ones actually hit the event at a certain time period. And we're going to use this one really mathematical trick. The log of a product is equal to the sum of the logs. And we do this because you can sum things in SQL, but you can't take the product of things in SQL. So if we take the log of this entire estimator, then we can change it to the sum of the logs, and then we can exponentiate it back out to get it into the right frame. So you'd format your main table as an ID, so you can find out when you end up debugging, which when gave you an error. The event time, if it hit the event time. So a lot of these are going to be null because they're going to be censored. You don't know when they're going to hit the event time. And the time seen. So how many, in my case, it's days, but it's however many time units that you've seen the item for. So our first SQL trick is we're going to generate a list of numbers. And what we can do this by selecting the row number from any table that is big enough. In this case, I want 3,000. So we'll select the row number and we'll get the numbers 1 through 3,000. And we'll get them from any big table that has enough 3,000. And this is because I want to get, I'm generating my TI so that I can then do the math. And then we have the horrible SQL slide, and I'm sorry for this, but hopefully we can get through this. So we left join to that day shift table. So we have our outside table is that list of 1 to 3,000. And then we select for each day, we get the day number. And then we're actually just computing 1 minus DI over NI exactly in this table. So 1 minus the sum of the case when time seen equals day num. So when we've seen them for exactly this long, and event time is not null. So when they have actually hit the event. Over the sum of 1, because we're using the join to actually say where time seen is greater than or equal to day num. So that's all of the NI that we have seen at least that long, that we see for longer. And there's a little having here to throw out any lines where there are no time scenes that end on that day num. This final step is just doing that exponentiation and the sum. So it's taking the natural log of 1 minus di over ni, summing those up, and then exponentiating to get the product. We do have to use a window function, so because we want to look at how we want to take that product over all the TI up to this point. So it's between unbounded preceding and current row. So it's all the previous ones. And then when you get what you get at the end, it's just a simple table that has the day num 1 through 3, all the way through 3,000, and the estimated survival, the proportion that survive at that point. Wait, but I gave you 2 curves earlier. How do I get 2 curves? So I could do them separately. You can also do them all in one big SQL thing, just like this. All you have to do is get your extra variable, in this case billing period, but it could be customer type or something like that. And you would put it in your main table. You would select day num, comma, billing period in your survival step. And then when you go to take the actual exponentiation and the log, you would partition by the additional variable. And that's going to do them one at a time. Just like grouping them by it, just does them one at a time in the previous step. And you end up with something like this, where you have for day 1, because I ordered by day num, for day 1 you have annual and then monthly, and you have the survival for each of those. And then for day 2 you have annual and then monthly, and the survival for each of those. So time to event analysis is pretty cool. And it can actually help you a couple of different ways. If you actually need to know the average time until an event, that's an option for you. If you just want to look at the curve and really understand a process and be able to talk about the probabilities of different things, that's something you can get out of this. And really what we found to be the most useful for answering business questions is to compare curves from different groups and see what's going on with different groups of customers. So that's it. Thank you so much. You have a break after this. I don't yet. I still have to answer some questions for the Q&A, which you can't see until you undo your screen sharing. Nope, here it is. And there are no questions.
Yeah, if folks have questions for Melissa, please do go ahead and post in the Q&A, and remember to upvote the ones that you'd like to see answered. We'll just give it a minute, and if there aren't any questions right now, you can connect with her offline, and we'll just go to break.
Yep, I've got a couple of slots open still in Umbrella if people want to talk later. Okay, a couple of questions have come up, so we have a minute still, right? We have a couple of minutes.
Yeah, we have a couple minutes left.
All right, awesome. Thanks for thanking me for the talk. Appreciate it. Can you talk about what changes your company makes when comparing monthly to yearly subscribers? Do you mean what changes we make to try and make, I'm not sure what you mean. I'm not sure if you mean something like what changes we make to try and encourage people to be annual because of what we've learned, or something else. So if you could come back and add some moments on that would help. What are some examples of when you would use this analysis besides when customers cancel a subscription? I'd like to do more with, so we have people sign up and then there's a certain time until they become paid. And I'd like to do more analysis of that. And that would do, so that would give us some other things to do it. Some people, we also have this notion that people invite customers. Anything you can think of that's an event that could happen is something you could use this kind of analysis with. So anything that's how long until they started using a given feature or something like that is something that you could use this for. When you compare the two curves of different groups, do you compare by just looking at the viz, or are there statistical tests to compare differences? So we did chapter 1, just chapter 1 of survival analysis. But there are a whole bunch of stuff about how you can include covariates and actually test the differences in the curves. Because I'm doing it just there in the SQL, I'm not computing the confidence intervals around them or anything like that. And so I mostly am just looking at the visualization, but that's an option available to you, especially if you're able to do it in Python or R. Okay, so more detail about the monthly to yearly subscribers. What does the data analysis tell your company to do? What business questions are you asking in order to prompt this analysis? So we're trying to figure out, we always offered both a monthly and an annual subscription. And anecdotally, we knew that annual subscribers were more likely to stick around, but we didn't know by how much. And so this really helped us answer that question and get a feel for what was going on and what the difference in the dynamics were. And it tells us that they're more likely to stay by so much more, that we're really incentivized to give people discounts to sign up annually, or to give them special onboarding and other additional help if they're willing to be annual customers. Is the monthly versus yearly divide driven by initial selection, or is there a self-selection issue at play? This is wise. There's absolutely some chance that there's some self-selection there, and people who are more likely to stay longer are more likely to have annual subscriptions because they're just those people. And there's not a really good way to tell them apart, as far as I know, in the analysis. And when you get to other kinds of ways of breaking up the customers, that becomes even more of a question. Did the customers who all chose this particular plan, did they choose it because they're the kind of customers who stick around for a really long time, or is there something else at play? And it's hard to tell, but we can nudge people to use to behaviors that we see sticking around for longer because we want them to pay for longer. And then as the curves do or don't stack up and become closer together, we learn a little bit more about whether those dynamics are real. This survival analysis textbook is by Kleinbaum and Klein. And I have not read the whole thing, but chapter 1 is really good.
All right, it looks like that was the last question. Thank you, Melissa. And now it's